Hi, everybody. Today we're starting section 2.4, 3.4, and that is a very, very important technique called integration by substitution. Extremely useful and important technique in integration. So here we go. Can you see me? Very good. So let's say we have an integral like this, the integral of 2x over the square root of 5 plus x squared. Now, this is something that's a little bit different than what we've seen. Okay. Now, let me notice something. I want to point out something I just noticed here. That we have an x squared here, and we have a 2x there. And we know that the derivative of x squared is equal to 2x. That is going to be very important. But actually, more than that, the derivative of x squared plus 5 is also equal to 2x. That is really important. That's what's going to launch this whole process. So let me rewrite this whole thing now that I've defaced it. So we have the integral of 2x over the square root of 5 plus x squared dx. And I'm gonna let create a new variable u, and u is gonna equal 5 plus x squared, which is that guy right there, that big guy right there. That's u. Now what's cool about this is that du equal to 2x dx. Now, usually we would say, by the way, normally we till now, we've always just said du dx equals 2x, and we kind of bring the dx over to the other side. That's where this comes from. Now, that's really important because 2x dx really is this thing right there. That's 2x dx. And this here is u. So that means that this integral that we had over here is equal to du, because 2x dx is just du, over the square root of u. That's it. And that's equal to, now I'm going to write this in exponent form, makes it a lot easier. U to the negative 1/2 du. And we know that this is going to be equal to u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. Let's never forget our plus c. And that equals, let's clean it up a little bit, to u to the 1/2 and of course plus c. Now we can't celebrate just quite yet. We can't just start celebrating right away, because what's u? Our original problem had an x in it. Where does this? What was u? We don't know anything about a u. Well, we know because we made that substitution. So now I'm going to back substitute, and this is equal to 2 times the square root of 5 plus x squared plus c. And that is my final answer. Now, what I'd like to do is take the derivative here, and I want to see that the derivative does work to get back to our original, function. B, that's going to help us taking the derivative will help give us a little bit of insight of why this whole method worked to begin with. So I'm starting with, I want to take the derivative of 2 times, I'm going to write it as parenthesis, as an exponent rather than a radical, 5 plus x squared to the 1/2 power plus c, and I want to take the derivative of that whole thing. Well, I have the 2 that just comes to the right. Now here, this is a chain rule situation, because I have a function 5 plus x squared inside another function, which is that exponent to the 1/2 power. Now the chain rule is no coincidence that there's a tremendous, as we'll see, there's a distinct connection between substitution and chain rule. and those two go hand in hand. But let's just take the derivative of this. Let's do the outer derivative first. Is 1/2. So this 1/2 comes out to the front, and then times 5 plus x squared to the negative 1/2 because I'm doing 1/2 minus 1, which becomes negative 1/2 times the and this all was the outer derivative, this part here, times the inner derivative, which is, let me just write that, inner, which is just 2x. And the c is gone. The derivative of c is just 0. Well, this half and that 2 cancel, and I'm left with, I have 2x times 5 plus x squared to the negative 1/2 power, which if I rewrite this in radical form, this is 2x over the square root of 5 plus x squared. And that's a fraction. And that, my friend, is exactly what we started out with. 2x over the square root of 5 plus x squared. So A, this works. And B, if you notice that we did a chain rule. And the inner derivative is the 2. The outer was the 5 plus x squared. The inner was the 2x. Well, notice that the 5 plus x squared and the 2x, those are the things that presented in the original problem. So basically, so again, my 2x was my inner, my 5 plus x was my outer. So you're gonna have your inner is gonna be there, and your outer is gonna be in there, and that's when the substitution applies. The substitution doesn't work with every single problem in the world, but when you're lucky enough to have this situation where you have sort of like a reverse chain rule situation, then substitution will work, and it's beautiful. So let's do another problem just to cement this a little bit. Okay, let's look at this problem right here. The integral of e to the x over e to the x plus 15 to the third power. So notice that on the bottom I have an e to the x plus 15, and the derivative of that is just going to be plain e to the x. So there's my that's going to be my, this is going to want to be my inner, that's going to want to be my outer. So let's just do it. I'm going to let u equal e to the x plus 15. Let me rewrite that so it's nicer. I'm going to let u equal e to the x plus 15, and du is equal to e to the x dx. Today's National Mess Up Day. Du is equal to e to the x dx. Okay, so it happens on live TV. So, and notice that e to the x times dx, that's exactly what I have over here. That's e to the x dx. So this becomes the integral of du over u to the third power, which is equal to the integral of u to the negative 3 power du, and that's again a very easy integral to integrate just with the power rule. That's going to be equal to u to the negative 2 over negative 2, because I add 1 to negative 3, get negative 2, divide by that same thing, and this equals, well, negative 1 over 2 square root of u plus c. And that's equal to negative 1 over 2 square root of e to the, oh crap. Oh, sorry, I messed all it up. Not the whole thing, part of the thing. That's not a square root, I think. This is equal to negative 1 over 2u squared, which is equal to negative 1 plus c, of course, which is equal to, plus c is not part of the fraction, negative 1 over 2 e to the x plus 15 squared plus c. So let me write that a little bit nicer. -1 over 2 e to the x plus 15 squared. And that is the answer right there. That's our answer right there. Okay, everybody, I'm going to end this video. Then I'm going to make a part 2 video, going into this a little bit more, giving a more precise mathematical definition, and doing more examples. So we'll see you guys next time. Bye.